So I want to give you a little bit of a lesson today on how to work a restriction mapping problem. So this diagram here is what is called a restriction map, and it shows a map of a plasmid. So remember, we talked about plasmids yesterday. Plasmids are this circular shaped DNA molecule inside a bacterial cell, and they have genes on them, but they replicate separately from the normal bacterial chromosome, which contains most of its genetic material. So this is the restriction map for the plasmid PGen101. The total length of that plasmid is 20 kb, which stands for 20 kilobases. And so we can look at the restriction enzymes that are used here. So they've used BAM-HI, and then they've also used EcoR1. And so depending on whether or not, depending on the restriction enzyme that you treat the plasmid with, determines where it cuts. So remember, restriction enzymes all have a specific sequence that they recognize, and they cut at that sequence. EcoR1 is only shown once on here. That means that whatever its sequence is was only seen once on that plasmid's DNA. BAM-HI, however, cuts in 3 different spots, and that means that sequence was detected 3 times. So what we want to look at here, the size of the fragment obtained. So if EcoR1 makes its cut, it's going to be 1 fragment. It's just basically going to stretch out and be a linear molecule of DNA. And it's going to be the full length long. So it's going to be 20 kilobases, okay? And you should get that by adding 8 plus 6 plus 2 plus 4, or just knowing that the whole thing was 20. All of these, each line has to total to be 20. All right. Now, if you used BAM, so we've got a BAM here, a BAM here, and a BAM here, and we're going to ignore EcoR1 for this one, then you would have one that was 2 kilobases. You would have a piece that's 6 kilobases. You would have a piece that goes from this BAM to this BAM, which is going to be 8 plus 4 kilobases. So 2, 6, and then 8 plus 4 is 12 kilobases. So it cuts more times. And again, notice that 2 plus 6 plus 12 still adds up to the 20 kilobase total length. Okay? And then the last one, if you take into consideration both of the restriction enzymes used together, BAM-HI and EcoRI, I think those are supposed to technically be Roman numerals, and so they're 1. But you would have the 4, the 2, the 6, and then the 8. Okay, so 2, 4, 6, and 8. And again, those still add up to that 20 total kilobases. All right. So on the next one, you are going to draw your own restriction map, given this information shown here. Okay, now there's not a great way to really tell you how to do that. Some of them are easier than others. AP is not usually known to give really hard ones, but there is one at the end that's a little bit harder. It's just kind of a puzzle. It's kind of a trial and error process. What I will point out to you on this one is that the total length is going to be that 26 kilobases, and that here 3 and 3, 4 and 4, 6 and 6, and then there's 2 6s here. That's what that 2 in parentheses means. There's 2 pieces that are 6 kilobases long. Those all match up. And then you have 13 here, and then the 7 plus that extra 6. And so that 7 plus 6 go together to make that 13. And so, the HPAI, its cut is going to be basically in the middle of one of the HEND 3, the long 13 segment of HEND 3, and it will divide it into a 6 and a 7. So use that information and see if you can't do that one, okay? Let's look at the next page. First of all, let me say this page has a little typo on it. This should be 1.94 kilobases. That was a mistake on my part. But if you look at this plasmid, what we want to do is we want to convert this to what it would look like in a gel electrophoresis. So here, in this first well, we're going to put DNA that's been digested with EcoR1 and PST1, okay? So, EcoR1 is going to cut it here, PST1 is going to cut it here. So we're going to have this fragment, that's going to be one fragment, and then we're going to have this fragment. So we know one of them is going to be 0.46. So we'll draw that in down here under the 0.5 and we'll just label it as 0.46. Okay? And then we're going to have another fragment that's going to be the sum of 1.94 and 0.2. So that would be, if my math is good, 2.14. So that's going to be somewhere in between here. 2.14. Okay? And then you would do the same for this one and for this one, just using the diagram, the restriction map, to determine how the plasmid's going to cut. Okay? Number 3 is pretty much the same, except you have to draw the restriction map. Number 6, you have to draw a restriction map. Number 5 is very slightly different. Basically, it wants to know what would be the products of a digestion. So it's wanting to know how many bases long something's going to be. So if we're digesting with the two enzymes EcoR1 and EAGI1, it's going to cut here, it's going to cut here, and that's all. So this piece is going to be between base 1 and 942. So we would say that it's 942 base pairs long, or kilobases long. Okay? And then again from 942 all the way back around to 541. So whatever that subtracts out to be. But these two numbers together should accumulate to that total of 5,541 kilobases in length. Okay, so that's it for the lesson on restriction mapping. If you have any questions, then let me know.